Okay, now we're going to learn about the cube root parent function. So previous lesson we talked about the cubic function, y equals x cubed. Well, if we take the inverse of that function, if we swap x and y, we end up with the cube root. So let's look at the graph of our cube root. So basic equation, again, it's the inverse of our cubic. So cube root x. So let's look at the graph. Let's graph a couple of points so that we see what the basic shape of the graph is, and we can define some key attributes. Well, since I need to take the cube root, let's pick some easy numbers that we can actually cube root, okay? So we need numbers that are cubes. So I'm going to plug in, let's do -8, -1, 0, 1, and 8. So if we look at -8, what's the cube root of -8? What number can I multiply 3 times to get -8? And that's going to be -2. So we can graph that point, -8, 1, 2, 3, 4, 5, 6, 7, 8. Got to extend my graph. And we get -8, -2. Cube root of -1 is just going to be -1. Cube root of 0 is 0. Cube root of +1 is +1. And cube root of 8 is +2. So notice here is my parent function of cube root. Notice it still has an S shape, but it's a sideways S. Okay, remember x cubed graph was kind of an up and down S. This one is going to be a sideways S. Notice also we still have our rotational symmetry, point symmetry about the origin. Okay, so cube root functions are also going to have rotational symmetry. I can turn that graph 180 degrees and the graph will be exactly the same. So let's look at key attributes. Domain. Do I have any restrictions on domain? Notice I can plug in any positive x, I can plug in any negative x. So domain is just like the cubic function, all real numbers. So -infinity to infinity. Now what about the range? The range again is exactly the same. I have no restrictions. I can get positive outputs, I can get negative outputs. So -infinity to infinity. And again, for the parent function, the x and the y-intercept is the origin. But of course, if we apply transformations, move that up, down, left, right, that could change. So let's do some examples of identifying the different transformations from our cubic functions. So what if I don't have plain Jane parent function? What if I have a pizzazzed up function? What if I have -2 cube root x plus 4? How is this graph gonna look differently from the parent function? Well, our transformation rules still apply. Notice, let's start here. I have a +4 under the radical. So under the radical means inside. Inside, think opposite. So +4 really means we're going to be moving left 4. Notice I have a negative on the outside. A negative being multiplied is always a reflection over the x. And I have a 2 being multiplied on the outside. Multiplying on the outside is always a vertical stretch, or is always vertical. And then because 2 is greater than 1, it's a vertical stretch by 2. So think about graphically, what's that going to look like? And we can draw a quick sketch. You can also graph it on your calculator if needed. So, but if we draw a quick sketch of the graph, I would start with our translation of left 4. So typically we start at 0, 0. But because I'm moving it left 4, that means that I'm going to not be intersecting at the origin. I'm going to be intersecting at -4, 0. And this one's a little tricky because we are reflecting it over the x. So typically our graph would be going over to up to the right, but because we're reflecting it over the x, it's going to be going the other way. So this one, if you want to graph it on your calculator to find exactly what it will look like, that's fine. Our vertical stretch, think about it. If you vertically stretch yourself, you're going to get tall or skinnier. So some key points, it will actually go through 0, -3. But our reflection over the x is going to make it go up this way, and it will S down this way. So definitely a rough sketch. You can graph it on your calculator if you want it exact. But notice, key attributes. Did our domain range change at all? No, unless we have a real world problem. So domain is still -infinity to infinity. Range is still -infinity to infinity. But notice our x and our y intercepts did change. Okay, our x-intercept is -4, our y-intercept is 0, -3. But transformation rules, they don't change, they stay the same. So let's try another one. What about y equals cube root x minus 2 plus 1? So this one's not too bad. All we have are translations, up, down, left, or right. So let's start with the outside. If I have +1 on the outside, that means I'm moving it up 1. If I have -2 on the inside, think opposite, that's going to be moving it right 2. So this one's not too hard to sketch out. If we draw a rough sketch, typically I start at 0, 0, but I'm moving it right 2 and I'm moving it up 1. So my point of rotation is going to be at 2, 1. And we're not stretching, compressing, we're not reflecting it. So it's just going to be going up 1 this way and go down that way. So you can, again, graph it on your calculator. Oh, moving my graph. Again, you can graph it on your